Hello, everybody, and welcome to Virtual reInvent. We're here today to talk about how to use a networking construct in AWS, the VPC endpoint, as part of what we call your data perimeter. And what we really mean by that is your strategy for securing your data and workloads in the cloud. But what we're really going to talk about is the story of this networking construct. It's been around for a couple of years. We've had VPC endpoints in AWS since 2015. And many of you are probably familiar with the concept of VPC endpoints, maybe are already using them. Some of you probably are not. Don't worry, we're going to explain everything. But if we sort of start from the beginning, this is when, this excerpt here of a press release from 2015 is when we at AWS first launched the VPC endpoint. In fact, my name is Becky Weiss. I'm an engineer at AWS, and I've actually had the privilege at AWS of working on multiple of the technologies surrounding VPC endpoints over the time. At the time, in 2015, I was working on our VPC team. And so we launched this VPC endpoint product. And in addition to telling you how to use the VPC endpoint as part of your data perimeter today, I'm also going to give you a little bit of, for the AWS geeks out there, a little bit of the history of how this networking primitive came to be and how it became such an important part of this strategy. So we're going to do a little bit of history, a little bit of under the hood geek interest, and of course, it's a reInvent talk. You're going to get your how-tos and best practices. So when we launched the VPC endpoint in 2015, and you'll notice here, this slide's looking a little bit different than the other slides that you're probably seeing in the other reInvent talks. I'm using kind of the retro icons we used to use to draw AWS things back in 2015. We launched it, we had pictures like this. I'll explain this picture in a little bit. But that is what this talk is. This talk is both practical advice for builders in the cloud, as well as a little bit of history, how we got there, why things are the way they are, and maybe a little bit of technical interest stuff about how it actually works. And all of that information, my hope is, will help make you very effective in configuring your networks to get the most out of the security controls that they offer you as a customer of AWS. Start at the beginning. A brief history of the Amazon EC2 network. So here's the thing. Some of you may know this, some of you may not, but in the early days, EC2 was, it was one of the earlier AWS services out there. It was groundbreaking. It was virtual machines in the cloud. And EC2 actually existed before the VPC, before the virtual private cloud product existed. Now, if you use EC2 today, you might wonder how that could be so, because these two concepts are so closely interwoven today. In the early days of EC2, it was something that we now call EC2 Classic. You spun up an EC2 instance, and what you got is a virtual machine running in a big flat network that was owned by Amazon. It was a 10/8 network. That meant 10.0.0, 10.something.something.something. You launched an EC2 instance in there, and it came with a private IP address, and that means an IP address in that 10 dot range, which meant that if it wanted to communicate with other EC2 instances in that network, it would communicate with them over that 10 dot range. It was a flat network. Everything had connectivity to everything else. Of course, we also had the concept of security groups, meaning that you could create we still have this concept, sort of a simple elastic concept for container for defining who can talk to whom, but the connectivity, the basic connectivity between EC2 instances was there. When you launched an EC2 instance, you also always got a publicly routable IPv4 address, either one that you had specifically allocated as an elastic IP address or one that got assigned to you, but you always had connectivity from the outside. Now, like I said before, the security group rules were still there. You didn't necessarily have connectivity from the outside, but the routability was definitely there. And, there were a few other AWS services at the time, not nearly as many as there are today, but Amazon S3, the simple storage service, that definitely existed, in fact, even older than EC2. And many of your workloads running on EC2, well, of course, they would be storing data in S3. reading and writing their data in the cloud. And so when they wanted to talk to the S3 service, if you've ever used S3, you know that you make request to its API, get object, put object, list objects, things like that. Well, you're talking to the S3 endpoint in AWS, and that's what your EC2 instance did. S3 was out there at a publicly accessible endpoint, and your EC2 instance could reach it because it had routability to the internet, and that is how that worked. So those were the early days of EC2. EC2, as I think comes as a surprise to nobody here at reInvent, was a pretty big success. And as we talked to the customers using EC2, many of these enterprise customers, as EC2 is gaining more and more adoption in more and more industries, they were saying, you know, actually, we would like to control more aspects of the network. And one of the main reasons for that is these customers said, you know, we plan to use both infrastructure in the cloud and infrastructure in our on-premises network, connectivity between them. Here's the thing, though, our on-premises network has an IP address range that's going to conflict with your EC2 range. Like, that's on a 10 dot range as well. So they asked us, you know, can you give us a network? Can you let us control the network for our EC2 instances? And that is where the concept of the virtual private cloud came about. So now we're, you know, circa 2009 or so, the virtual private cloud product comes about. And for the, you know, the initial product here, it was a network that customers controlled, and it was the ability to connect it with, you know, what we now call a site-to-site VPN with an on-premises network. So that was the virtual private cloud concept. And, you know, probably many of you have configured or looked at a virtual private cloud, or are certainly working within one that was set up by somebody else. And you know the way this thing is set up. It's a network where you get to decide what the IP address space is. You get to divide up that IP address space into subnets that live in one of our availability zones. Some of these subnets are public. Some of these subnets are private. If you're ever wondering what those words mean, I mean, beyond their just colloquial meanings in English, well, our specific meaning, you know, when you see us talking about public subnets, that means it has a route to the internet, and private subnets that don't have a route to the internet. Now, this was great because it gave customers, our enterprise customers, a great deal of control over exactly how their network would work and how routing would work in this network. So, you know, these customers, they use these public subnets and the private subnets. For the public subnet, in the public subnets, they would put infrastructure that they intended to be reachable and communicating directly with the internet. For example, in this picture here, I might have a workload that's fronted by external facing load balancers. Well, you know, if I have a workload like this, I certainly want the internet being able to communicate with my load balancers, but everything behind that, the backend servers, the databases, and so forth, well, I consider these private infrastructures, so they don't need any routability to and from the internet, and they certainly don't need to be directly reachable from there. So I'd configure my infrastructure like that. And that's all well and good, as long as we're talking about infrastructure that I put somewhere in my VPC where I control the routing rules. But once again, a lot of these customers, they're not just using EC2, they're making use of our growing, you know, rapidly growing array of AWS services that let them, you know, store their data and get value from their data and messaging and notifications and so forth. And, you know, of course, the great power of all of these AWS services that they're using, it's the W in AWS, it's a web service. These things, you know, when they used S3, they didn't have to provision some amount of storage in their VPC. They just put object, and S3 scales to support their needs. That's kind of the magic of the cloud there. So these customers, their data is in S3. They're taking full advantage of it. They're growing. They're successful. And you might notice that this S3 thing that you're using, where you're putting your data, it's not in your VPC. You never set it up in your VPC. In fact, when you go to reach S3, in fact, if you go right now and resolve the DNS name for the S3 endpoint in some region, you will see that this is a public IP address. This is an IP address on the internet by design that anybody can send packets to. Of course, the question of whether you can make successful requests to S3 is a question of authentication and authorization, but from a pure networking perspective, it's a public endpoint. Anybody can get to it. Now, if I just take a real close look here, though, I notice that the IP address where S3 is, it's not in my VPC. Here I've set up a VPC on a 172 dot range, and S3, definitely, by its IP address, definitely not in my VPC. And so what that means, if it's not in my VPC, the way VPC routing works, to send anything outside my VPC, well, I need a route to wherever it is that it's going. And so customers, had set up their VPC with private subnets and public subnets, and they observed that in order to reach S3, if they had infrastructure in their private subnet that needed to reach S3, they would need an internet gateway. For their public subnets, they would need some sort of NAT, network address translation, in order to be able to get the traffic to and get the return traffic back. And that is how they had to reach S3, because S3 was not in their VPC. So, it didn't take long for customers to start asking us, can I get S3 in my VPC? I notice I need to leave my VPC to get S3, but my EC2 instances are in AWS and my data is in S3 in AWS. Why am I having to, go to the internet in order to get to S3? Or very technically, why am I having to configure an internet gateway in this route that is, that seems like it's going out of my VPC? Can't I bring that data into my network? Now, of course, I just explained that from a very sort of network-centric perspective, what S3 in my VPC means. I just showed you how S3 is not in your VPC. But one of the cool things, I've worked for AWS for quite some time, and one of the really cool things about working here is the way our culture treats us to listen to our customers. So our customers were saying, bring S3 into our VPC. And as we were sort of digging into that, can you bring S3 into my VPC? We kind of heard a bunch of other themes around, well, why? Okay, so first of all, there's the obvious one. S3 is not in your VPC. From a network connectivity perspective, I need a route outside of my VPC to get to this IP address. Is very clearly not in my VPC. So, if you look at it from a very surface perspective, you're kind of asking for something like this. No longer having to go through this internet gateway to get to S3. I want some kind of a direct route to that out of my VPC. But digging in, it means a little bit more than that. What is it? Why would you actually want to bring your storage, quote, into your VPC? Well, we kind of heard two reasons for that. So, first of all, many customers at the time, and still do, consider their network to be part of their security primitive. Now, a network is never the part of their security perimeter. A network is never the only part of your security perimeter. Like, it's never really a great security best practice to allow access to something just because it seems to be coming from the right network. You've probably read a lot about that. But it is certainly useful as a signal. Things inside my network might be okay. Things outside, access from outside my network, maybe I'm not expecting that at all, so I just like to exclude it. So that's one reason why you might want to bring the data that you're storing, quote, inside your VPC. Because if you can bring it inside your VPC, maybe you can make rules about the network locations from which it can be accessed. Maybe you can make rules like, if they're trying to access it from outside my VPC or from outside expected network locations, you can just sort of deny that access no matter what else is going on. Again, you never use it to allow access unilaterally, but it is an important signal, an important condition. There's another thing that it means too, as we sort of learned about how customers think about this. Again, many of these customers think about their network as part of their security perimeter, and what that means to them is they have rules set up on the edge of the network about where data can flow when it originates from this network. And what that means, if you're talking about a cloud service like S3, what that would in particular mean is that, okay, I've got a bunch of workloads running in this network, running in this VPC. I know they access data in the cloud. I know they access data in S3. but I actually know exactly what parts of S3 that they're supposed to be accessing, what parts they're supposed to be reading, what parts they're supposed to be writing. And I'd like to make rules about that. I'd like to make sure that the parts of S3 that get used by the workloads in the VPC, which I know what they are, that it goes to the locations in S3 that it expects and not locations in S3 that I'm not expecting. So S3 in my VPC might give me a way to assert that. And so summing that all up, what does S3 in my VPC mean exactly? Well, there was that connectivity thing we saw first, but there's actually two things that sort of start to bleed into the area of authentication and authorization. I probably want to use this network as a way to defend my data, to be able to assert that access to the data is coming from the network I expect. And conversely, I also want to be able to use this network as a perimeter to make rules about the S3 interactions that are originating in this network and where they get to go. Okay, so took all of that into account. In 2015, we launched the Gateway VPC endpoint. We didn't use the word gateway at the time. The word gateway came in a little bit later, but I'm going to use it now because that's the word we use for it today. And it actually does explain sort of the technical underpinnings of this VPC endpoint this very first VPC endpoint that we launched. The idea was this: S3 in my VPC without a need for an internet gateway. And the word gateway is significant here. If you've ever looked at routing in a VPC, this VPC endpoint was done with routing. Now, if you've never seen a route table in a VPC, they're actually fairly straightforward, and I can kind of explain what you're seeing here. But in a VPC, all of the rules about where packets go are dictated by these route tables. You're looking at some route tables right here. And when you have a gateway VPC endpoint, your route tables are accounting for that. I'll show you exactly how. What's going on here is I'm showing you a route table that I have. It's got three rules in it. The first rule that you see here is a rule that's always in your VPC route table. It's basically saying if the packet seems to be going somewhere in the VPC, I'm going to route it locally. That just makes connectivity among your VPC work. Second one that you see here is one that's sending traffic. These aren't evaluated in the order you see them. They're evaluated according to most specific. But the second one you see here is sort of the catch-all. Everything that isn't covered by another rule, where I send it, that stuff's bound for the internet and I want it to get there. The third rule here is your VPC endpoint rule. Now, you'll notice here that the destination isn't really specified in terms of anything that looks like IP addresses, but over on the right-hand side, it's sending the packets to the VPC endpoint. So the thing on the left-hand side is something called a prefix list. You may have seen prefix lists in VPC. It's a pretty simple concept. A prefix list is, well, a list of IP address prefixes. This one is the one for S3. In the region that you're looking at here. It's a list of the well-known IP address ranges that the S3 public endpoint is in. In fact, if you go and resolve the s3.amazonaws.com or the variant for whatever region that you're in, you will get an IP address that's in one of these ranges. All right, now what that all means in a route table, that means that if a packet is bound for S3, just bound for the normal public endpoint for S3. It's going to match this route because it's going to match one of the prefixes in this prefix list, and it's going to get sent to this gateway VPC endpoint. It's not going to go through your internet gateway, and that means that you can reach S3 without taking a general route to the internet. So great. We have accomplished our connectivity goal for VPC endpoints, and we now have the ability to route traffic to S3 without needing a route to the internet. The other thing I'm going to point out here is because this is done with routes, this also means that all these workloads running here in my VPC, they're running code, maybe built against the AWS SDK, maybe something else. They're all reaching S3 at its well-known public endpoint. The code doesn't need to change. In fact, DNS doesn't need to change. The code does what it does. The DNS resolves the way it should. The public, you get an IP address that's somewhere in one of those ranges for S3, and then you take the VPC endpoint there. But remember, that was only one of the 3 things that we were trying to accomplish with this VPC endpoint, connectivity. The other things had to do with authorization. So this VPC endpoint, when it launched, came with a couple of other features. The first feature is we baked the understanding of this network path into our authorization logic, into our authorization logic in AWS. And what that means specifically is when a request reaches S3 over a VPC endpoint, and of course, S3's first job is to do authentication and authorization, make sure that whoever's calling actually has permission to do what they're trying to do in S3. The VPC endpoint, like the fact that the packet came from this particular VPC over this particular VPC endpoint, they are part of what we call the authorization context. And that's a fancy way of saying that your request has the network path marked as an attribute that you can write policies about. So for example, what you're seeing here on the screen, if you don't read and write IAM policies every day, I will kind of translate this one to you. What this policy statement says, it's attached to an S3 bucket, so it's gonna get evaluated every time anybody tries to access this S3 bucket for any reason. It's saying if anybody tries to access this bucket, I don't care who they are, and if they are not coming over, and if they're, get object, if they're trying to read a specific thing, if they're not coming over this specific VPC endpoint, then that seems to me to be an unexpected scenario. It's coming from an unexpected network location. It's not coming from my VPC. I would like to reject that request. Now, of course, those of you who know IAM know that this is just a deny statement. So it blocks access. Of course, you also use S3 bucket policy statements to allow access in various scenarios. I'm not showing you that, but there might be other statements in this policy that are allowing various kinds of access, but no matter what, if it's coming from the wrong, I'm asserting the network location. If it's coming from the wrong network location, I do not want it. And by the way, one thing that's neat about IAM, you're probably aware that there's a number of places that you can write these IAM policies. IAM is IAM, which means that the same kinds of policy statements, they take effect regardless of whether they're attached to the bucket, which I just showed you, or whether they're attached to the caller, which I'm showing you now. Here I have that little funny red hat in AWS is how we denote the IAM role or the IAM principle. Basically, it means an identity in our identity system in AWS that has policies associated with them. They have various permissions. So this IAM role, I have created it to run as part of a workload in my VPC. In other words, the only place I expect this IAM role to show up and do anything is in this VPC. So in order to assert that, in order to be able to use my network as perimeter, in order to be able to use my network as a second layer of control in making sure that my data stays where I want it to, that my credentials are used from where I expect them to, in addition to whatever other allow statements are on this IAM principle that I'm not showing you, this IAM principle, for example, probably has permission to do some things with S3. I also have this statement. I say, you know what? I don't care what you're doing, but this role belongs in the VPC, so if they ever try to do anything not from within the VPC, I'm just going to say no. This is an assertion. It goes along with whatever other things I say are allowed. So that's the second part, right? I just showed you how both on the caller and on the S3 bucket, I'm able to use the network origin of the request as part of my authorization context to make decisions to basically exclude access from the networks I'm not expecting. And then finally, there was that third part. Now that I have this VPC endpoint, can I use it to control the kinds of requests that get made over it? And the answer is yes. And we did that by introducing a new kind of IAM policy. This policy is attached not to the caller, not to the bucket, but to the network, to the VPC endpoint. Now, because it's on a VPC endpoint, and a VPC endpoint doesn't really take action, it doesn't really have permission to do anything, It's expressed in terms of what you might think of as a boundary, sort of as a gating policy. Basically, when a request goes through this VPC endpoint, it must pass the policy. Nothing in this VPC endpoint policy can grant access to anybody to do anything because, like I said, a VPC endpoint doesn't actually do anything. But when this role makes a request through the VPC endpoint to the S3 bucket, the VPC endpoints policy gets evaluated, and these policies are usually written in pretty coarse terms. And you got to pass before you even are allowed to make the request. So the policy that you're looking at here, again, if you're in the habit of reading IAM policies, but you've never seen a VPC endpoint policy, the alarm bells might be going off in your head. You're like, did she just put an allow policy here that allows all principals to take all actions? Well, that's because this policy doesn't grant anybody permission to do anything. It's a statement of who gets let through. So this policy is asserting that, okay, if they're going to use this VPC endpoint to talk to S3, I know that from this VPC is mine. I know that the only identities, the only IAM principals that I ever expect to show up and try to reach S3 from this VPC are from my AWS organization. That's a group of accounts that go together for the sake of billing and other controls. They better be from the organization. If they're not, then that's kind of unexpected, and I want the request to just not get through the VPC endpoint. So that's sort of our third thing, using the endpoint as a point of control over what goes on. So in summary, we talked about the connectivity thing. This slide is sort of giving you a summary of sort of the two sides of the authorization capability of S3 in my VPC as manifested by the VPC endpoint to S3. Over on the left-hand side of the slide, you see examples of ways to use the network origin of requests to decide whether they should or shouldn't get access, or specifically to decide that they shouldn't get access because they're coming from the wrong network. And over on the right-hand side, it's a way to make rules about everything that happens to S3 from this network, which are typically pretty coarse-grained rules like must be my identities, or must be to S3 buckets that I own, or must be even to a certain set of S3 buckets that I know. Typically these rules are about the writing of data. Okay, great. Mission accomplished. So the customers say, great. As S3 is not the only AWS service in the world. Can you go ahead and do that for all of the other services? And this is a very reasonable request. Particularly that VPC endpoint policy capability is extremely powerful in being able to make rules about how AWS services get used from within your network perimeter. Okay, so what were we learning about gateway VPC endpoints? Now that these things were out there, they got adopted very, very rapidly. So the cool thing about these gateway VPC endpoints is they're done with routes. So like I said before, nobody's changing any code in order to use them. In fact, nobody's even changing how DNS works. Once you have an IP address that goes to S3 that matches one of these prefix lists, one of the prefixes in the prefix list to S3, you're good to go. You get routed to the VPC endpoint. You remember at the beginning I was saying that one of the initial impetus for us to create the VPC product was these customers with on-premise networks. These things are done with routes, and so you have customers with some workloads that are in EC2 in their VPC talking to S3, and some workloads that are on premises also talking to S3. And these customers say, great, we love this VPC endpoint. We love that the policy lets you essentially create to create some rules around how S3 should get used from this. From my network. Can I extend that to my on-premises network? And there's a little bit of a problem here. The problem here is that this is done with routes. And if you've ever set up connectivity to an on-premises network, like with a site-to-site VPN or a direct connect, or nowadays with transit gateways, well, hang on a second, those are done with routes too. And so you can't really do that, right? Because you can route VPC-bound traffic from the on-premises network, no problem. You already, that's part of how you set up your VPN. But how do you route traffic into the VPC endpoint that didn't even seem to be bound for the VPC? So we needed to kind of solve that problem as well as we were extending this concept of S3 in my VPC to all of the other services. Now, there were a number of other innovations at the time. So this brings us, the years I'm talking about here are like 2016, 2017, that kind of era. Around that time, we were also innovating in a number of other areas in networking in EC2. We developed this internal technology that we've talked about as hyperplane. This technology actually powers quite a few things that you're probably using in AWS today. The first public launch that made use of this capability was our NAT Gateway product that we launched. I think it was about 2015 as well. We launched the NAT Gateway product, and if you think about, again, this is all sort of under the hood kind of geek interest detail. You don't need to be following this part in order to be fully effective with the VPC endpoints. But I know that some folks are definitely interested in this here. If you think about what it takes to do NAT, network address translation, on the way to the internet, well, you do need something stateful in there that's tracking the flows as they go up and as they go down. Because imagine I have this EC2 instance, 172.31.51.39. It's sitting in my private subnet. It wants to make outbound requests to the internet and, of course, get responses back from the internet, but it doesn't want to have a public IP address. It doesn't want to have any kind of direct routability to and from the internet. So how would that have to work? Well, so there certainly does have to be a publicly routable return address. Otherwise, how is the internet going to send those return packets back to me? And so that NAT gateway that you might set up in your public subnets, that gateway, it actually does have public IP addresses. If you've ever set it up, you know that you had to configure an elastic IP address to go with it. And that NAT gateway has inside of it this hyperplane technology that's doing the flow tracking. Basically, the request, the outbound request comes from my EC2 instance. It remembers that this flow, to this destination on the internet is coming from my EC2 instance, from this private IP address in my VPC. It changes the source IP address to be the public IP address where the internet can talk back, sends the request out. The request comes back to the NAT gateway. Of course, the NAT gateway has to now remember it's been tracking the state. It needs to remember where to send the reply. So we had built the technology that's able to do that. It was pretty flexible technology, actually. It was the same technology behind the network load balancer that we introduced shortly thereafter. The network load balancer was our, it sort of complemented our application load balancer, which is our layer 7 load balancer. This network load balancer is our layer 4 load balancer. And the cool thing about the network load balancer is that it presented a stable IP address for the load balancer. And you might wonder how that would work. Well, the answer is actually very, very similar to that spiel I just gave you with NAT Gateway with slightly different choreography. In order to keep a stable IP address, but actually route it to, any number of these backends, yeah, you do still need some stateful tracking of the request. And using this hyperplane technology is how we ultimately extended this VPC endpoint concept, AWS service in my VPC, to lots of other services. So this was an announcement from 2007, from reInvent-ish 2017, where we announced that AWS Private Link, that's what we called it, was available for a set of first couple of AWS services. What this really was, what a private link is, in fact, you can set up a private link for your own services. And you'll notice that one of the really powerful capabilities of private link is it can give you cross VPC, even cross account connectivity from clients of a service to where the service is by kind of projecting that service to a network load balancer into the VPC that's going to call it. Well, this is exactly what we did for our AWS services. These AWS services with a private link VPC endpoint were able to get connectivity in their VPC to these AWS services that were otherwise, were and continue to be reachable at public endpoints. Now, but hang on a second. the networking mechanics that I just described are quite different from what I described earlier as the gateway VPC endpoint. If I take Kinesis as an example, Kinesis is available at a public endpoint just like S3. But when you set up a VPC endpoint to Kinesis, and I'm using this as an example because it was one of the first of the private link, or what we call interface VPC endpoints, what you got was not a prefix list and some routes and a gateway. Rather, you got Kinesis planted at an IP address in your VPC. Actually, if you've ever set one of these up, you know that you create one of these in each of the availability zones that you use. So imagine this picture times 3. It was just too many boxes to put on the diagram. So you actually have 3 of these, but each of these VPC endpoints to Kinesis is actually now at an IP address in your VPC. It's something we call an ENI, an Elastic Network Interface, a private IP in your VPC. This thing's actually at an address in my VPC. Now that solved one of our core problems with the gateway VPC endpoint to S3, which was, remember, these customers with their on-premises networks. With a VPC endpoint that's actually at an address in the VPC, the routing now all works. If these on-premise servers, they want to reach Kinesis, but they want to go through the VPC endpoint to Kinesis, they now can, right? Because this traffic, if they send a packet to 172.31.51.41, that's great. It goes over their direct connect route and ends up in the VPC and ends up going through that VPC endpoint. All right, great. So I've got Kinesis in my VPC now, but like I said, things are a little bit different here. For example, imagine, you're seeing some EC2 instance, it's calling Kinesis. It's probably going to be using a DNS name to talk to Kinesis. I mean, even if you use the SDKs under the hood are constructing the regional DNS name to whatever service that you're talking about. So I've got a little bit of a question for you. If I'm a workload running on this instance and I want to resolve the DNS name, kinesis.useast2.amazonaws.com, let's say all of this is running in our Ohio region, well, what's the right answer for that when I resolve that DNS name? Is it the public, Kinesis in Ohio has a public IP address. It might look something like that. Is it that address in the VPC? Is it something else? And if you think about it, well, it has to be that address in your VPC. In order to go through the VPC endpoint, in order to get credit for going through the VPC endpoint for authorization purposes, it's got to be B. It's got to be the VPC endpoint. And in fact, if you set up an interface VPC endpoint in your VPC to any one of these services, and then you go into the VPC and you resolve the DNS name, you will indeed see that you get, whatever, you may have set up like 3 of these, one in each availability zone, and you'll get an answer for each in your VPC. You'll get a different answer in your VPC than you would out in the world resolving the same DNS name. You might wonder, who did that? How did that happen? Well, that's one of the cool things that VPC endpoints does for you is you set up. If you've ever set up one of these in the console, you notice that there's a checkbox. The right answer is to check it. What happens if you choose that is that your Route 53 resolver, and what those words mean, that means DNS in your VPC is going to create a special record for you so that when you resolve that DNS name, rather than giving you the general answer that anybody would get out in the world, you get these private IP addresses. Some of you might be familiar with Route 53, Route 53 resolver and the specific feature called private hosted zones that makes that happen. We've had that in AWS since probably about 2014. It's a really powerful capability that lets you control DNS from inside your VPC, lets you make your own rules for how DNS works in the VPC. So that's precisely what VPC does for you when you create one of these private link endpoints. So in fact, you can go and take a look at that. Your VPC endpoint will show you all of these names that get created. And it's actually worth, if you're curious about how all of this hangs together, you'll notice that actually some of these records, like the VPC E dash, whatever the identifier is, these are actually public DNS records, you can go resolve them from anywhere. Of course, they resolve to the RFC 1918 IP addresses from within your VPC, so you're not really going to be able to reach them from outside your VPC. But these DNS names are created anywhere and everywhere, and the general, kinesis.useast2.amazonaws.com result in your VPC using one of these private hosted zones that AWS kind of creates behind the scenes on your behalf, does that resolution for you. You might also be wondering, well, how do those names work, right? If you know anything about how the establishment of a TLS connection works, well, it's, the certificate's got to match the DNS name you were talking to. It's kind of the whole point of TLS. And you will notice if you go, this incantation, if you've ever had to troubleshoot a TLS thing, you're probably familiar with this incantation. Basically, I'm hitting the Kinesis public endpoint and dumping out its certificate and looking at it. And you'll see that it actually does have that wildcard name that's going to match my VPC endpoint names. And that's how the whole thing works under the hood. You don't actually need to know that to use the VPC endpoint, because it all kind of gets set up for you, and you just take your applications and they're written to use the AWS SDK to talk to Kinesis, and the AWS SDK picks up this, uses the regular DNS name because of that Route 53 change made in your VPC. It magically resolves to the right thing, and you're off to the races with your VPC endpoint. If you ever wondered exactly how that all works, I just explained it to you. Like that is what's going on under the hood. So that's really cool. I've got Kinesis. I've got Kinesis in my VPC. I can talk to it from my. I can talk to it from from my on-premises network over a direct connect. A couple of years later, we launched support for the VPC endpoint policy, so you get all of the authorization benefits of the VPC endpoint as well. But hey, back to S3, right? Customers really want to write those VPC endpoints for VPC. They have these on-premises networks. So customers were asking us, can you offer this? The gateway VPC endpoints for S3 worked really well, got gangbusters adoption. We have loads of customers using them. There's actually very little downside. We had customers saying no, and I actually also need the interface VPC endpoint for this particular picture because of my on-premises network, and I want it covered by my policy. So earlier this year, right at the beginning of 2021, we launched the interface VPC endpoint for S3. Now, again, I'm going to sort of go, if you use one of these, and I'm going to explain in a few slides, because we have these two different kinds of VPC endpoints for S3 now, which one you should pick for which use cases. The spoiler alert is in most cases you should use the gateway VPC endpoint. But the interface VPC endpoint, because of how S3 works, there's a couple of things to know about how the interface VPC endpoint to S3. One thing you might know, if you've ever kind of looked under the hood, you may have had the chance to notice this in the past. You may not have, right? The S in S3 is for simple, and a lot of this is kind of taken care of for you by our SDKs. But if you ever looked at the DNS name that you're accessing when you're making these, just regular old API calls to S3, you'll notice that it's not, the DNS name isn't typically s3.region.amazonaws.com like you'd see with the other AWS services, but it's rather DNS names that we call virtual hosted DNS names. And they look kind of like this. When you make a request to just let me list the objects in the bucket, and you turn on debug in the AWS CLI, which is cool because it shows you the exact details of the request and the response, you'll notice that the request doesn't go to s3.useast1.amazon.aws.com. It goes to mybucket.s3.useast1.amazonaws.com. So S3 is a slightly different way of being addressed. And what that means is that the DNS specifics are a little bit different. And in fact, when you create one of these VPC endpoints to S3, one thing to be aware of is you actually do need to, unlike the other services, you do need to configure an alternative endpoint. The endpoint is going to be bucket dot, not the bucket name, like actually the string bucket dot your VPC endpoint ID dot S3 dot, and you see the rest of this. There's a special endpoint to talk to. And that is basically to accommodate these virtual hosted, these virtual hosted style ways of addressing S3. You'll also notice that the, again, if you're curious and you go and you dump the certificate you go and take that bucket.vpc endpoint whatever, and you go and dump out the certificates from that, you're actually going to see why the certificates of that match your endpoint. You're going to see actually a certificate that was created especially for you. Okay, so two kinds of endpoints in S3. S3 is the only service with two kinds of endpoints. S3 is also the most commonly used service for VPC endpoints, for reasons that probably aren't very hard to guess at, just because so many customers use S3 for so many things. We got the gateway and the interface. Which should you use? The answer is usually you should use the gateway VPC endpoint, and the reason is cost. The gateway VPC endpoint. The gateway VPC endpoint doesn't have any per hour or per gigabyte charges. It's basically just a route that's sending traffic like any other route in your VPC endpoint. It also requires no changes to clients, as we talked about before. Same code, same DNS name, same DNS resolution, same IP address, and the rest is just done with routes. The times when it makes sense to use an interface VPC endpoint is if you are one of these customers with an on-premises network and you want that VPC endpoint policy to also cover what's going on premises, that's when you use that interface VPC endpoint. Everybody loves a flow chart, so I drew a flow chart for you. What do? And oh, by the way, you can have both, right? If you think about how I described the network mechanics of each, the gateway VPC endpoint's done with routes, the interface VPC endpoint's sitting at an IP address in your VPC. These absolutely work side by side. So if you have some workloads on premises that you want covered by the VPC endpoint, as well as a whole bunch of workloads running in your VPC, what you should do is you should set up the gateway VPC endpoint, have all your workloads from the VPC, use the normal DNS name for S3 and just send their traffic out that way. And then for the specific traffic that's coming from on-premises, you can, what you would do is you would use the VPC endpoint specific DNS name to get that traffic through your VPC endpoint and get that policy applied. So the answer, usually, use the gateway VPC endpoint unless you have some kind of an on-premises situation that you would like covered by the VPC endpoint policy. All right, so enough history. You're a builder. You're at reInvent. You want to know, what does this all mean to me? What should I do about it? So I'm going to quickly go over the sort of the main strategies that customers we see our customers using to get the most out of the security properties of this VPC endpoint. So the first thing, I alluded to this before, a VPC endpoint allows you to tie your identities into your network. Like this IAM role is denoted by this funny red hat inside my VPC. I know because I deployed this IAM role to run on these EC2 instances. I know the IAM role belongs in the VPC, doesn't belong anywhere except the VPC. So in addition to whatever other allow statements that are letting it do its job, I'm also going to add this deny statement that says, no, like this IAM role can take no actions if it's coming from the wrong network. So the cool animation here is that I have locked my IAM role inside my VPC because that's where it belongs. Now, as we were working with more and more customers who were trying to enact this strategy, and as more and more higher level AWS services got built that sort of sit kind of on top of S3, adding value to it, and I'll give you Athena here as an example. If you haven't used Athena, it's a fabulous service. What it lets you do is it lets you take database structured data in S3 and just query it directly. Totally serverlessly, you're not provisioning anything, you're not spinning up any cluster of anything, you just send a query and it figures it out with your data in S3. It's pretty magical. And what does Athena do? How does Athena work? Well, I make a API call to Athena, it's called Start Query Execution. With my identity, I make a request to Athena. Athena makes an onward request on my behalf to a bunch of data in S3 that it's going to start riffling through to be able to answer my query. Now, of course, that second hop, Athena to S3, is that coming from my VPC? No, it is not coming from my VPC, right? Athena's not in my VPC, neither is S3. So this second hop of the request doesn't get credit for being in my VPC endpoint. But yet, I know that this is a request, this is the kind of request that I want to allow. This is sort of in bounds in terms of my perimeter. So we launched, we launched maybe about a year or so ago, we launched in IAM, we launched an IAM condition called via AWS service that lets you account for those higher level services that are making onward calls on your behalf. So this is something good to know about if you're writing one of these lock the identity inside the VPC kind of policies. This kind of thing is a simplifier because it will let you also account for these other patterns that you probably want to allow. And what this policy now says is the request needs to start in my VPC. I'm okay with letting services continue my request, from wherever network they're in, but I need to make sure that when this role's credentials get used, it's starting from my VPC. Very, very similarly, and we talked about this before, I can tie my bucket to my network. And using exactly the same tactics, those source VPC and source VPC endpoint IAM conditions. Now, of course, it is very common. Again, there are many AWS services out there in a growing set, and we're here at reInvent, so that set is growing even as I speak. We have a set of AWS services that interact with your S3 bucket. They write their data there, they read your data from it, and they're interacting. When they interact with your bucket, they are not in your network. These are services that are in AWS that are adding value to your data. So how do you do that? Well, again, as we focused on these perimeter scenarios that our customers wanted to accomplish, and this particular use case of I would like to lock my bucket inside my VPC endpoint, but I would still like to enable all the goodness that AWS services can offer with it. Well, for that, we already talked about the via AWS service for when the requests originate from my VPC, but the second hop doesn't. But then there's a second simplifier here. If I expect AWS services to be interacting with my bucket under their own identity, then I can also account for those traffic patterns in my lock my bucket into my VPC policy. And by the way, the principle is AWS service. The times to go looking for it as part of your network perimeter strategy is if you ever find yourself on an S3 bucket writing a policy statement that, allow principal service CloudTrail.AmazonAWS.com or any number of other service.AmazonAWS.com, that means an AWS service is going to be interacting with your bucket under its own identity. It's not going to be coming from your network. You can still lock your bucket into the VPC. You just have to account for that principal as AWS service case. So that's another perimeter tactic that we see customers increasingly using successfully to be able to lock their data into their network. Finally, to focus on this VPC endpoint policy that we talked about, and just as a reminder, what this policy does is this policy just makes rules that cover the whole network about how it must or must not use S3. We saw this policy before that asserted, we see many customers writing policies like this that assert that if anybody's talking to S3 from this network, it's got to be an identity that I'm expecting, an identity for my organization. There's some other things that you can do with this as well. For example, S3 in particular, last winter we launched a new IAM condition in S3. It's called resource account, and it is what it sounds like. When this bit of context is attached to your request, whenever you access anything in S3, any object or bucket in S3, it's assigned to, well, who owns that bucket? And by doing that, I can make rules for my VPC. If I know that all of the rights to buckets are going to be for buckets owned by account 1 or buckets owned by account 2, but not anybody else, I can write this policy here. I can say, if somebody's writing data to an S3 bucket from anywhere in this network, I don't care who they are, I don't care why they're doing it, it's got to be a bucket that's owned by one of these accounts, and it allows me to make an assertion like that. Now, I'm going to kind of wrap up this talk by acknowledging, I've talked a lot about VPC endpoints are a lot about being able to control the kind of net traffic that leaves your VPC, specifically on its way to various AWS services, S3 and others. Now, I just wanted to acknowledge, though, of course, the world is much bigger than that. If you're looking to manage outbound traffic, there are a number of AWS services that you should know about. This talk is not primarily focused on them, but I just want to mention them because, as you're thinking about this theme of things, these are also very much worth looking at, because it's definitely true. We're talking about control of outbound traffic, assertions you want to make about what can and cannot happen. Well, there's traffic to AWS, and we've talked about that for the last hour. But there's traffic to everything that isn't AWS out on the internet that you also may wish to have some controls over. So one thing to realize is one form of traffic that you are probably sending out to the world is DNS, right? I talked a little bit about the Route 53 resolver that works for you in EC2. It's got a lot of pretty cool capabilities. By default, its job is to resolve DNS for you in your EC2, taking into account both the private hosted zones that you might have, as well as, DNS names on the internet. So it will recurse out your request to wherever it needs to go by default to be able to get you an answer. But it actually gives you more control than that. If you want to control what kinds of requests actually go out to the internet and how they get resolved, you can actually make use of a feature on your Route 53 resolver. It's called the Route 53 Resolver DNS Firewall to make rules about what happens for different kinds of DNS resolutions that it's doing for you. So on a domain basis, you can make different rules. You can say, I want to allow these things to resolve. I definitely don't want these things to go out and get resolved. Or I just want to have alerting or logging. I just want to see that these things are getting resolved. So you have control over the DNS traffic that's leaving your VPC. Of course, once you've resolved DNS as your first step to sending a request somewhere on the network, of course, then you may also wish to control other types of other kinds of outbound traffic leaving your VPC. And that's where a service called AWS Network Firewall comes in. It's got a lot of really powerful capabilities. The architecture for this, if you look at how to set this up, it typically involves putting up a third kind of subnet as the network firewall subnet. This is basically a way to get all of your traffic routed through the network firewall before the firewall endpoint before it goes and hits the world. And what you've got there is an array of stateful, stateless, packet inspection. If you're familiar with Suricata rules, it's compatible with those rules to be able to control the kinds of traffic that's leaving your network. So that was just a few words on kind of the larger picture here. Back to this concept of VPC endpoints as your tool for using your network as an important part of your security perimeters, your data perimeter strategy in AWS. We've actually got a little more content here at reInvent on that particular topic because it's been an area of intense focus for many teams here at AWS as we listen to what's important to our customers as they're using the cloud and securing their data in the cloud. Two that I want to call out in particular. One of them is a session that's going to be both pre-recorded and shown at reInvent about with a customer of ours, Goldman Sachs, talking about how they actually put these strategies into practice. So if you want to get a customer's perspective on how to do this successfully, I think that will be a great talk. And then finally, at the reInvent event, we're going to have a workshop that actually gives you a little bit of direct experience with building these data perimeters using the various kinds of IAM conditions and network controls that we've been talking about here. So I wanted to thank you very much for watching this kind of history and under the hood and how to for VPC endpoints, the network part of your data perimeter strategy.